Introduction.
What is alloy? Alloy is a material composed of a metallic base and additional metal or non-metal elements. Alloys are typically created to obtain desirable material properties that otherwise are not present in the primary base material's pure form. While metals are commonly used as alloying addition, non-metals primarily are often used too. In general, alloys are stronger, harder, more durable, and sometimes more corrosion resistant than their pure metal counterparts. The exact composition of an alloy will vary depending on the type of base metal and its alloying element. Alloys are divided into two types. First, substitutional alloys. Substitutional alloys form when one metal substitutes another metal, atom or similar size in the metal lattice. Forms via atom exchange mechanism. Common substitutional alloys are brass and bronze. This is a figure of substitutional alloy. Second, we have interstitial alloys. Interstitial alloys form when small atoms insert into the holes of the metal lattice. Forms via the interstitial mechanism. A common example of an interstitial alloy is steel. This is a figure of interstitial alloy. Characteristics will vary widely depending on the type of alloy. First, improved properties. Alloys are created by combining two or more metals or elements. The resulting material typically has improved properties compared to its constituent parts. For example, steel is stronger and more durable than iron alone, and bronze is harder and more corrosion resistant than pure copper. Second, customizability. Alloys enable desirable properties that do not exist in the original pure metals to be obtained. For instance, aluminum alloys are much stronger and harder compared to pure aluminum, which is soft and malleable. Third, diversity. Several hundred different alloys currently exist. Alloys have been created to serve many different applications. New alloys are also constantly being developed. Fourth, strength. Alloys are stronger than their pure metal counterparts. Additional elements in the base metal lattice structure make it harder for atoms to move around, which makes the material stronger. Fifth, corrosion resistant. Several hundred different alloys currently exist. Alloys have been created to serve many different applications. New alloys are also constantly being developed. Sixth, electrical conductivity. Alloys tend to have lower electrical conductivity than pure metals. The addition of atoms with different charges in the lattice structure of the base metal can interfere with the flow of electrons through an alloy. 7. Thermal conductivity. Alloys tend to have lower thermal conductivity than pure metal. A metal's ability to conduct heat is dependent on the number of free electrons within its atom. The addition of atoms with different charges in the lattice structure of the base metal can interfere with the flow of electrons through an alloy. Different types of alloy. First, steel. All steel are based on the element iron with all small amount, less than 2% of carbon added. Other intentional alloying elements added to improve or alter the properties of steel include manganese, nickel, chromium, and vanadium. Many other elements may be added for specific purposes and all be present as residual, while exact properties may differ based on chemical composition. In general, when compared to pure iron, steel is stronger, harder, and tougher but less ductile. Some steel alloys, such as stainless steel, are also corrosion resistant. Steel is one of the most commonly used metals today. It is often used in building, ship and watercraft, automobile, medical equipment, household applications, and tool. Second, brass. Brass is an alloy composed of approximately 66.6% copper and 33.3% zinc. However, many brass alloys that are variations on this basic formula have been developed. These may contain such additional alloying element as aluminium, antimony, iron, or silicon. In general, brass is stronger, harder, less dense, and more easily machinable than pure copper. Brass is often used in weapon, hardware, ammunition cartridge cases, and marine applications. Third, bronze. Bronze is an alloy composed of approximately 88% copper and 20% tin. Additional elements such as aluminium, phosphorus, manganese, and silicon are also sometimes added. Compared to pure copper, bronze is stronger, harder, more corrosion resistant, and easier to cast. Bronze is often used in sculptures, gears, bushing, and tools. 4. Aluminium alloy. Aluminium alloys are made by combining aluminium with smaller amount of elements such as manganese, copper, magnesium, silicon, and zinc. Several hundred different aluminium alloys exist. Compared to pure aluminium, aluminium alloys are stronger, with strength sometimes rivaling steel, harder, more durable, and more corrosion resistant. Aluminium alloys are used in a wide range of applications including automobile, airplane, medical equipment, consumer product, wiring, and electronics. 5th, titanium alloy. Titanium alloys are composed of a titanium-based metal and additional elements such as aluminium, manganese, zirconium, chromium, and cobalt. While pure titanium is already one of the strongest elements, titanium alloys are even stronger. Additionally, titanium alloys are more flexible and corrosion resistant. They are often used in aircraft and automotive components, marine application, and medical devices and equipment. 6. Nickel alloy. Nickel alloys are composed of nickel base and other elements such as iron, chromium, and copper. Nickel alloys are stronger and exhibit desirable magnetic and thermal properties than pure nickel. Nickel alloys are often used in electrical components and electronics. 7. Copper-nickel alloy. Copper-nickel CuNi alloys are primarily composed of copper and nickel, but sometimes include other elements such as silicon, iron, manganese, and zinc to obtain different properties. The properties obtained differ depending on the exact chemical composition of the CuNi alloy. Generally, copper-nickel alloys are excellent electrical conductors, are corrosion resistant, and have high tensile strength. CuNi alloys are commonly used in electronics, marine applications, and pipeline. In conclusion, after exploring about alloys, we know that alloys is a fusion of different metals, exemplify the strength found in diversity, proving that a blend of elements can create a substance stronger and more resilient than its individual parts. After that, alloys have their own benefits, just like better strength, more versatility, increased hardness, can have increased corrosion resistance, and more cost effective. Alloys have limitations, for example, less ductile, difficult to weld, difficulty in recycling, can be more prone to corrosion, and environmental concern. Little did we know that we actually use alloy in our life, from building material, transportation, electronic, medical devices, and more. As we incorporate this compound into our life to let us know deeper knowledge about chemistry.
Don't stay up too late, but I gotta let you know that you've been on my mind. It's taken a while for me to say it, hope it's fine. And I wouldn't mind if you were taking up my time.